How would I do number 3? So number 3 is what we call an accumulation function. You're going to want to watch the video from yesterday because that's when we started to go over those. So it's an accumulation function. So L of x accumulates from 1 to x on f of t, and that's a graph of f. So L of 3, like if you think back to when you first learned about functions, if you have L of x, and then you're supposed to find L of 3, doesn't that mean that wherever you see an x specifically, you put a 3?
Yeah.
So that's where I'd start. I'd say L of 3 equals the integral from 1 to 3 of f of t dt. So then f of t, right, because the 3 goes in for x. The 3 does not go in for like whatever variable, it specifically goes in for x. So then the question just becomes, how on earth am I supposed to evaluate that integral from 1 to 3? I think you can answer that with one word. Specifically, what part of geometry? Area, yeah. So remember that a definite integral is just a summation of like really skinny rectangular areas.
Yeah.
So if I can figure out how to get that, and it's that weird, like, it looks like a triangle but then has a curvy part.
Mm-hmm.
If I can figure out kind of a geometric strategy and area to get that area, that's where I want to go.
Okay.
So that might take a little bit of thinking to get there, at least on part of it, but that's where we're going to go. You guys all done? Whoa, yeah, like you look at this, like, where in the heck did your integral go? You didn't do FTC2, did you? I think you did. I think you derived and dropped. So you shouldn't be doing that because it's not ddx of a definite integral. It's just a definite integral. Number 3 is not an AP test question, but it very easily could be. Number 3 is a question that I actually wrote for ETS, for the AP test. They rejected it because they said that they already had one like it. So I said, darn, God, I tried. But they said it was a good question, so I thought I'll use it. Just know that there could be one like this in some form or fashion coming up. Maybe even this year, who knows?
Is there a way to
No need to do a calculator.
this?
Ooh, I don't think there's any need, yeah, there is, for sure, but there's no need to do a Riemann sum. I would just be doing area. Like literally, I would look at this and I would say, that's a triangle. It's a 1 by 1 triangle. And then I would use the fact that you have a semicircular graph. The fact that it's not just some random curve, that it's a semicircle, really important. When you just drawing a line there, when you say area of this, what are you talking about? Okay, so the area of the semicircle, gotcha. Yep, agreed.
I have a 4 minus 1.
Not a bad plan. There's other ways to do it, but that's not a bad plan. So you said, I think it's a little bit more complicated, but my way is just slightly less complicated. I think your way is totally. You said, will you check my thinking? I think there's some good geometry strategy. What you doing?
Email checking.
No. No, no, no. Please don't. Email can wait. Texting, Instagram, TikTok, whatever anything you're wasting time with.
Moving forward, things
We are moving forward too, and here's my issue, is when you're distracted with that, we continue to move forward, and later on you're like, oh man, I totally don't understand that, or I'm struggling, or whatever. I'm just thinking to myself, if only he had been fully engaged instead of half engaged, what could Merrick do? Because he has a pretty powerful brain, and when he's only using 1/3 of it, it's not that powerful. You get it? So if you like actually applied your whole brain to something instead of just 10% or 20% there, you'd probably be a lot better than wherever you are. And right now is decent, but you could probably be way better than decent. Just the distraction. Let's see here. Where are you guys at? I got maybe a couple more minutes here, so you need to wrap up with this warm-up set. Okay, well maybe you're ready to see some answers now. That's totally fine. So, where are they? There they are. Okay, so there's number one. Oh, it's frozen. There we go. So number one, it wants to know the average rate of change. That's also known as the average slope, or the slope of the secant line. And so I went ahead and I plugged in the 1 and I plugged in the -1. And I think I completed my unit circle trig correctly. And I got 0/2. Eventually 0.
No, well, because it was the fourth quadrant. So it's positive.
Yeah, cosine would be positive in the first and the fourth. Any questions on 1? Okay, then number 2. After all that work, I got an answer of 2. 2. So hopefully I added everything up right. Let's find out. So can you guys see how, just trace my steps with me and let's see. So right here, this is me getting my limits in the right order, right, going from left to right instead of the other way. And I pulled out the -2 constant. And then over here in the green box, this is me splitting the 2 terms that I saw in that second integral, and I pulled the 3 out also. I don't see any errors there. Then, on this step, I've got -2, and then so integral from -1 to 5 would just be the sum of 9 and -7. So it should be 2, so I think that's good. Antiderivative of x is 1/2 x squared, evaluated from 2 to 4. And then, so I'm thinking that second step that I have the arrow by looks good. Then so it'd be -4. And so it would be 1/2 of 16, which is 8. 1/2 of 4, which is 2. So that would be... yeah. 8 minus 2, which is 6. -4 minus 6. 3 times 4 is 12. I think that looks good. So what do y'all think? Maybe there's some steps I can explain a little bit better. I would just go over my work, making sure I didn't do some embarrassing thing like 3 plus 4 is 12. Or every now and then that happens, as you know. So, what can I answer for you? Any questions there on 2? There's a lot going on with 2 for sure, right? A lot of properties. I think most of them are up there, just in that one question. I'm just giving you a little bit of space here. Let me know if I can help. Okay, well, I'll get this other one up on the screen. We can still go back to number 2 if you want. But for those that are ready, there's number 3. And I just used geometry. So Maddie, what I did, because you had that really good idea before, what I did is I essentially found the area of this green square, which was 1 by 1, and so that's this right here. And then I subtracted off a fourth of the circle. But that's the same basic strategy that you used, so I don't know which one of us is more or less complicated, but it's the same idea. We should get to the same number. And then, of course, plus the triangle. The triangle is 1 by 1, so it's got an area of 1/2. So you just want to offer the opportunity for me to try to explain this differently or explain it better or something. If any of this is not very clear, please let me know. The stapler not sufficient. I've got binder clips if you want. Okay, so nobody is raising their hand. Nobody's saying anything. Does this mean we're okay? Think so. Hey, what could you do? Maybe you understand this scenario. What if, like, right now feels like you pretty much get it? You're like, oh man, totally should have had that. Okay, I get it now. That kind of thing. Have you ever had that moment where you're in class and you feel that way, and then 2, 3, 4, 5 hours later, it just comes back to your mind and you're like, oh man, I know I had it, but now I've forgotten it. What could somebody do if they were in that situation?
Watch the video.
They could watch the video. Like, I say this over and over. Listen, I say this over and over because in some ways I am so jealous of you, because in my day, if you zoned out or didn't totally get something or get time to answer the question, you were like sort of out of luck. You had to call a friend. You had to meet someone. You had to meet the teacher. You had to take a lot more of your time and get it all arranged with your schedule. Now all you got to do is go YouTube, or just go to Schoology, like a couple of clicks and you're there, right? And you can go back there and say, oh, that's what Luke meant when he asked that question. Maybe it's the second or third time you hear it and you're like, oh, Shirley is so smart. I can't believe she knew that. I totally went right over my head, but she knew it. Whatever. Maybe it takes that second or third try to get it. It's okay. All right. So we're good. Looks like awesome. So please, with me, go here. Got 2 examples for y'all to think about today. Let me zoom in here. This is just the next page over. And today is our final day of FTC. It's our final day of Unit 5. So as you can well imagine, that means tomorrow, it's Thursday, right? Tomorrow's Thursday. We're going to be into Unit 6, which is our second to last unit of the whole school year as far as regular new material. April is still looming large at the end, but as far as brand new stuff, there's just two more to go. So please do, in electronic or physical form, please bring Unit 6 with you tomorrow, okay? It's like March 5th. Or not March 5th, February 5th. Sorry, I'm off by a whole month. So it's like about 2 weeks away. Actually, it's exactly 2 weeks away. Exactly 2 weeks from today. Yeah. Okay, so number one, number one is going to have a couple of different parts. And my plan of attack here, just so you all know, so you can kind of get a lay of the land, my plan of attack is to kind of get us started in doing one part with you. And then I feel pretty confident that if I did one part with you, you could do some practicing, get some repetition on your own. So let's have you do the other parts after that, okay? So let's read this over here. Number one says, find the absolute extrema of f of x on the interval from -7 to 8, given the graph of f prime and that f of -2 is equal to 3. So here is, let me just give you an example of what someone mistakenly could do. They could look at this and see, oh, okay, absolute extrema. Well, isn't that just maximums and minimums? Okay, maximums and minimums. Well, all right. So the maximum is right there, and the minimum is right there. So the max is 3. The minimum is -3. Done. That was like the easiest question of the year. What mistake have I made if I did that?
That's a graph of f prime.
That's a graph of f prime, and we want to know the max and min of f, right? This is a really important thing, and people that should know better make this mistake sometimes. And so let's vow to not make that mistake, confusing f with f prime and what they mean. So let's go back. This is a phrase that you have seen quite a few times. You started seeing this back in like November, maybe late October, November, something like that. What are the candidates for absolute extrema? So where f prime is 0, or where f prime doesn't exist, or endpoints. So when Hunter says where f prime is 0 or where f prime doesn't exist, how could we label all those points? Critical points. There we go. So Jed, you're right. I don't know what you meant by circle. The circle. Oh, everything on the circle. Everything you circled. Yeah, exactly. So the short answer would be your candidates are critical points and endpoints. Those are your candidates. Okay, so let's figure out what our candidates would be. And I think I'll just do this off to the side. I'll make a little table of these candidates. So, what would be my lowest numerical candidate x value? -7, yep. All right, so that's one of the endpoints. What's the next candidate? -6. That is where f prime, I'll use Hunter's strategy of circling things for the moment. So there's the endpoint there on the left, the critical point at -6. There's another couple of critical points, right? Where are those other 2 critical points? -2 and 4. Good. And then, so that's this one here and that one there. And then the last candidate would be x equals 8. So those are all of my candidates. And I'm going to be trying to figure out what's the highest y value and what's the lowest y value. Once I figured those things out, I'll be finished. The good news is, that's a pretty big table, but the good news is, don't we already know one of the data points in the table? Which one do we know? That's right, f of -2 is 3. That was given to you. And really, the truth is, if we were going to do a question like this, you need to have at least one of those to make this work. So you do have one of them, so this will work just fine. So here's what I'd like to do. I'd like to explain how we approach this. I want to do one of these with you. I'll leave the other ones up to you, and you can make your final conclusion. So here is the basic strategy. I've given you a ton of information about f prime, like a whole graph about f prime, right? Yet I'm asking you for the maximums and minimums of f. So if I'm trying to take information about f prime and get it to be information about f, what process is going to have to show up somewhere?
Increasing, decreasing?
Yes, but what am I going to do?
Antiderivative.
I'm going to have to do an antiderivative, right? To go from a f prime to an f. Of course, the increasing, decreasing thing is going to matter ultimately, but I'm going to have to do an antiderivative to get specific enough for what I need. And even more specific than that, I'm going to do a definite integral. I'm going to put those, the little limits on there. So I want to set this first one up. My goal for my first effort is to handle this one right here. I want to figure out what's the y value for when x is -7. That's my first goal. So here would be my approach. I'm going to set this up as the integral from -7 to -2 of f prime of x dx. I need to do some work with this, but before I do, I want to explore like why. I think it's pretty clear why I would do the integral of f prime, right? Because I'm trying to get to f. But why would I pick the -7 and the -2 for my limits of integration? I know about f of -2, not f prime, but I know f of -2, and so that explains why the -2 is in there. That's going to give me what I want. That's exactly right. So he said that really well. I would say it briefly by saying one of my limits is the thing that I know, and the other thing is the thing that I want. I know about -2. I want to know about -7. And so I'm going to take what Reese said and I'll write it up there. According to FTC, fundamental theorem of calculus, wouldn't this equal this should equal f of -2 minus f of -7. Right? According to FTC. Like when you saw this 2 days ago, this was actually the very first presentation of the fundamental theorem. The antiderivative undoes the derivative. And you plug in, subtract, and then those two expressions are equal to each other. So I'm trying to set a pattern here for you on this sort of question. So as you all mentioned, we know from the table that f of 2 is 3. I don't know f of -7, but I do want to know it. How in the world am I supposed to evaluate that definite integral on the left? Hunter?
Area.
Couldn't I just use area? I hope you do. So, let's see here. I've got a little triangle over here. Oh, come on. So this little triangle here. What's the area of that little triangle?
6.
No, the very first one?
Sorry.
Isn't it 1 by 3? So 1.5? Yeah. So this, and we would probably write this as -1.5 since it's below the x-axis. I'm actually also noticing something else kind of interesting. Isn't this also a triangle of the exact same size, only above the x-axis?
Yep.
That might be a useful thing to notice. Why would I care about that?
Constant slope.
Well, they're just going to add out, aren't they? Yeah, because of the constant slope on that line segment. When I integrate or accumulate across that part, I'll just get 0 by the time I get to -5. I got to go all the way to -2 though. So this triangle here is what, 3 by 3? So that would be 4.5 for an area. And then, oh, and that's it, right? Because I'm going to -2. That's all I need for this one. Okay. So as I accumulate from left to right, I get -1.5 plus 1.5 plus 4.5. And do you see how the resulting equation for you guys is super easy? So this is 4.5. And I just need to solve for f of -7. So I would subtract the 3 and divide by a -1. So I'm coming up with -1.5 equals f of -7. So I can go over here to my little table and I can put -1.5. Okay. So what I would then ask you to consider here is you have 3 more candidates. You need to use a similar process, only it needs to be geared towards the number that you're shooting for. I would suggest that one of your limits always be -2. That make sense? One of your limits should always be -2. So this is where you got to be careful, right? Because what if you messed up on one of the other values and then you use that to calculate your next value?
True.
So now you're off again and again and again potentially. So my suggestion would be to always use the -2 because that's going to just stay the same. And then hopefully you don't mess up the arithmetic. We all do sometimes, but hopefully you don't. So anyways, if you guys would try to fill out the rest of your table, and filling that out would then, of course, allow you to get a final judgment on what the maximum is and what the minimum is. And we'll get that reported out from you guys here in a couple of minutes. I'm going to try to give you guys a chance to get out ahead of me, and then I'm going to try to fill in the rest of this myself for the video's sake, and also so we can kind of compare some answers too. Or if you're stuck, you can always take a peek. So I'm going to start working on -6 here in just a minute. And take a peek if you want. Whenever you're ready, I think I've got some answers up there for a table. And I'll go ahead and conclude. Let me know if you disagree, if you have a question. So I tried to color code it as best I could. So maybe we should go through. Do you guys agree with -6, -3? Which one are you working on?
It's gonna go from -6 to -2.
So from -6 to -2. Yeah, so -6 is right here.
Yeah.
-2 is right there. So I've got a 1.5 and a 4.5, which would give me a total of 6.
Yeah, for some reason I was doing -5 to 0. I'm not sure why.
Oh, okay.
Just looking at it wrong.
Well, we do use 0 a lot, so yeah, you just want to line it up with those critical points. Again, hey, I think I did this right. I don't have these answers memorized. If you have questions or it seems like I made some weird arithmetic error, maybe you're wrong, maybe I'm wrong. Okay, you agree? Cool. Well, at least we're on the same page. Question? Hey. You'll see the repetitious nature of this. Hopefully you can see if you can get one of these, as long as you don't make little arithmetic, geometry mistakes sort of things. You get the concept down, it's just a matter of repeating it a few times. Hopefully you see a good place. So if that table is correct, then I would want to call out my answers and actually answer the question. I have to say that the max is 3, and the minimum is -3. It just so happens that that -3 minimum does happen twice, but it's the lowest, so it's the minimum. All right, so just a moment to reflect, think, question, whatever. Okay, so I just have one more for you today. We're all good? Okay, so let's flip over to our other example. This other example is similar enough, but it is different. Can anybody notice, when you flip over to number 2 and look at it, can anybody notice what is different? So we got a graph of f. And we also have this g of x function, right? What kind of function is g of x? Accumulation. So notice maybe you remember from number 1, there was no accumulation function. It was just, here's the graph of f prime. Let's figure some stuff out about f. Here we have this actual accumulation function and a graph of f to go along with. I would say that A is very much review from yesterday. B involves some good stuff from yesterday and some really old stuff. And then C will be a little bit newer. So let's take a minute. I feel like you can probably do A, maybe, because it's like what we did. We did I think we did 5 of these or 4 of these yesterday. So please try A. Ready, go. Feel free to discuss, work together. Again, like before, since this is something you've seen before, I'll give you a little head start, and then I'll start working, and we can compare, and I'll explain as needed. If you're looking for a first step, I've got one up there. Looking for a second step? I've got that up there too. I think it's an important one to do. I went ahead and wrote some areas up there. I think I did that right. Ooh. went ahead and completed all the way through to what I believe is the answer for letter A. Once you get to a good place, let's compare, discuss. Peeking over shoulders, I saw a couple of folks that had 10 minus 2 pi instead of 2 pi minus 10. That negative out front would flip the signs. Be careful with that. Again, I would say this would be, like if you took your AP test, you saw one of these, I would not be surprised in the slightest. If you took my final exam or something, you saw one of these, it should not be surprising. Got to be able to handle the area of a circle, a triangle, a rectangle, something like that. In this case, maybe a couple squares. Don't be surprised. Definitely don't be surprised. Do you guys have any questions on A? Okay. So let's take a look at B then. It says find the critical point or points of g of x. So g would have critical points whenever what is going on? Yeah, or maybe it doesn't exist. So let's figure out g prime of x first. Maybe you could just do this in your heads. I don't know. What is g prime of x equal to? Yes, and how did you get there? Yeah, and it's the FTC2, right? It's the drop and derive routine. Yeah, so I agree. G prime of x is equal to f of x. I'm using FTC2 to get there. And as Reese mentioned, I need to set this equal to 0. So for what x values is g prime equals f equal to 0? Negative 2 and 2. Yep, you can see right there and right there. So that one was pretty straightforward. Negative 2 and 2 for your critical points. Make sure that if you want to get full credit on some test or quiz or whatever, make sure you have the thing in the green box up there. Don't just write x equals negative 2 and 2. Show me where you set the important stuff equal to 0. So endpoints are candidates for extrema, and we'll get to those at part C, but endpoints are not necessarily critical points. But that makes sense. So the word candidate, it's kind of hard because candidates and critical points they both start with letter C, so it's easy to get them mixed up. Yep. Candidates would be everything you should consider. Critical points is just one little category.
And then also, wouldn't the critical point be where it doesn't exist? So wouldn't it not exist at 0?
So something doesn't exist at 0. I would say that g prime, which is equal to f, definitely exists at 0. In fact, the point is 0, 2. But something else doesn't exist at 0. Can anybody explain what doesn't? G double prime equals f prime doesn't exist at 0. That's right. So if I took the derivative again and got to g double prime equals f prime, that wouldn't exist there, or at 2 for that matter.
Yeah.
But we're just talking about g prime equals f.
That makes more sense.
So everything exists there.
Thank you.
Good question. That's my favorite question of the day right there. It's good stuff. The reason why it's my favorite is I probably wouldn't have talked about it except you asked, so it was worth talking about. Okay, so C says find the absolute min and max of g of x. So what are your candidates? What should you even consider? What kinds of things? There you go. Endpoints and critical points. We already found the critical points, so that's not going to be too hard to find those. I'll make my little table over here. And I've got my x's. My candidates would be endpoints, which are negative 4 and 4. And then my critical points are negative 2 and 2. Oh, man. I need to see if I can move all these. Yes, I totally can. Okay, so those are all my candidates right there. And I'm looking for y equals g of x. So here's the good news. Don't I already know one of these already? Which one do I know? Well, I guess, you know what? I got to do a tiny bit of thinking to get to that one. I guess you could say I know 2 of them, don't I? So I know g of negative 4 because that's what I found in A. So that'd be 2 pi minus 10. And then Hunter's point is well taken in that when x is 2, don't you get the integral from 2 to 2? So the answer to that would just be 0. So right away without using a whole lot of brain power. I know two of them. I've just got to figure out the other two. And the way that I figure out the other two is simply a plug, input-output thing, right? So if I want -2, I would just say g of -2 equals, this would be the integral from 2 to -2 of f, which equals negative of the integral from -2 to 2, if I get my order in the more familiar order. And then from -2 to 2, what do I have going on here? I guess I got that little yellow area and the orange area. So I'm thinking that would be 4 minus pi plus 2. 6 minus pi. And then I would just do a similar process for the 4. This will be a little easier perhaps. So I would say g of 4 equals the integral from 2 to 4 of f of t. And so the integral from 2 to 4, that's that lone area that I didn't figure out. I'm going to color it blue.
Would it? Yeah, it would.
So yeah, it's a 2 by 1. And so that equals -1.
Wouldn't that integral, or for -2, wouldn't it be -6 plus 5? Because
Okay, slow down. So you're going back to the other one?
Yeah,
So the other one you said -6.
because you have that negative out in front by switching the bound.
Oh, did I lose my negative? You got to be kidding me. No, I fully admit it. I usually get things right, but every now and then I look at it and I just say, what was I thinking? So it should be pi minus 6, right? Let's fix that. But we got the -1 right, didn't we?
Yeah.
All right, so then there's that. This is where just a little bit of mental arithmetic will go a long way. 2 pi minus 10, isn't that roughly 6.28 minus 10? So it's like -3.7-ish. So if you wanted to put, approximately -3.7, pi minus 6, so that'd be 3.14 minus 6. That's like minus about 2.8. So -2.8 there. And then the other two obviously are very straightforward. Here you can say your final answer. You can say the max. That's in a bad spot. You can say the max is 0 and the min is -3.7. And that would conclude. That was really good timing. I went 3 seconds over. Hope you guys have a great day. I believe we have a quiz either tomorrow or Friday. Check your calendar. Is it tomorrow? Okay. On concept 15, which is the FTC. So be practicing, and let's get a good one tomorrow. Hope you guys have a great rest of your day.